Today we're going to be calculating linear magnification of drawings and the actual size of specimens in images of no magnification. We'll be working with this formula. To use it, all you need to do is cover up what you're trying to find. For example, to find specimen size, you would do image size divided by magnification. For example, let's start with these cells. These are onion cells. You can see here's a cell here, and a cell here, and a cell here. So for example, we may be asked to find the actual length of that cell. So in order to find the actual length of the cell, we're going to have to measure it to see what the length is on the image. So we're going to have to find the image size. So here we found the image size to be 32 millimeters. So if you divide that by the magnification of the drawing, which was 100, and that information is given to you, it gives you a specimen size of 0.32 millimeters. Recalling that 1 millimeter is 1000 micrometers, you can multiply the 0.32 millimeters by 1000 to get the specimen size in micrometers, a final answer of 320 micrometers. Okay, so let's review what we've just done. We have so far used the magnification given to calculate the specimen size, and we had a specific image for that. These were our onion cells right here, and they were magnified by 100. But what if we're not given the magnification? So if we're not given the magnification, we're given something known as a scale bar instead, then we need to start in a slightly different order. First, we're going to calculate the magnification using the scale bar as a tool to do so. Once we have the magnification from this, then we can follow the same steps we just did, use the magnification to calculate the specimen size. So here's an example of an image whereby we've been provided with what's known as a scale bar up in this corner right here, and we've been told that this scale bar, the length of the scale bar, is 10 micrometers. Of course, this is not the image size, and when you measure it, you're going to find that the image size is obviously larger. It's been magnified. So recall that we're going to use this scale bar here, first of all, to find out what the magnification of this image is, because we haven't been told yet. So the way that we're going to do that is like before. We're going to go ahead and measure that scale bar. So in order to find the magnification using the scale bar as a tool, we take the image size, that we measured, to be 2.6 centimeters or 26 millimeters, and we're going to divide it by the specimen size that we were told represented 10 micrometers. Now we have a small problem because our measurement is in millimeters. Dividing millimeters by micrometers doesn't work, so we convert the millimeters to micrometers. That gives us 26,000 micrometers divided by the specimen size of 10 micrometers. We achieve a final magnification of 2600. We have calculated magnification using scale bar as a tool. We found out that it was times 2600. So what we're going to now do is we're going to use that times 2600 magnification to calculate the actual specimen size of that cell. Now we can try and calculate the actual specimen width, if you like. Let's do the width. So if we measure the width with the ruler, we can run it through, and we find that the width is, say, 7.1 centimeters. So finding that the image width is 7.1 centimeters or 71 millimeters, and knowing the magnification is 2600 from our previous calculations, it's easy to get the specimen size simply by dividing the image size, 71 millimeters, by the magnification, which is 2600, we achieve a specimen size of 0.0273 millimeters. Once again, recalling that 1 millimeter is 1000 micrometers, we can achieve a final specimen size of 27.3 micrometers.